Okay, we should be back live. We are now recording and we are broadcasting, so welcome to our audience. We have somebody here in the studio in person. I will wait. It looks like stuff is back live. Let me verify that. Oh, Zoom is not. What's going on with Zoom? Yeah, Twitch is back. We gotta get Zoom back. There we are. Okay. It turns out when you have your discrete GPUs turned off to save battery, you can't use hardware accelerated video encoding. And I have to stop the stream to switch that on for recording. So your first quiz is on Thursday. Don't panic. This is the same material we talked about before. But for the people who weren't here last time, there will be 2 questions on the quiz. One of them, so the things I guarantee you will be on the quiz. You will need to interpret the 2 roots that the quadratic formula gives you, like the Roadrunner problem. You will need to treat motion with constant acceleration in 1 dimension, sort of like you did in the Roadrunner problem or the bicycle problem from homework 1 or the elevator problem from homework 2. You will also need to address motion with constant acceleration in 2 dimensions. So next Tuesday, that shouldn't be here, that refers to today. Things like what we'll do today and in recitation tomorrow. You will also need to interpret position, velocity, acceleration graphs like you did in the bicycle problem. So we have lots of opportunities for you to get help. Well, people are pointing out that I am too small. It's because I didn't push this button. Now I'm slightly bigger. So today I will be in the virtual physics clinic from 1:30 to 3:30. Wednesday from 4 to 7 I will be on Zoom. I don't think I'm going to do that in the virtual physics clinic, although I might. I will let you all know by email today where the review on Wednesday will be. And this thing on Wednesday is going to be designed specifically as a study session for the quiz on Thursday. And then finally on Thursday, for the first 20 minutes of class, we will be doing a review. You can ask last-minute questions. You can ask things about the homework. And then we'll have the quiz in the last hour of class. So the way the quiz works, I ate a red mushroom, good. The way the quiz will work is there will be a PDF that gets posted at 11:20 a.m. It will be due at 12:20 p.m. at the end of class, plus a grace period to give you time to scan and upload your work. Anybody who gets an extra time accommodation from the Center of Disability Resources will get that extra time. It's easiest if you take your 60 minutes and then whatever extra time you get right after that. But if you need an alternate schedule, please email me or come to my office hours and talk to me about that. I am way behind on answering email. A lot of people have sent me emails. Kelly, I know you sent me one. A lot of folks have sent me mail. I am so sorry I haven't replied. I did send out a blanket announcement yesterday about what to do if you have missed work. So take a look at that. The short version is if you have missed recitation, if you have missed work, don't worry. You can make it up before the next Tuesday with no loss of credit. My audio is a little low. Let's see what we can do about that. Thank you, Bridget, for telling me. So I'm going to fire up my... Okay, how is the audio now? Is that better, Bridget? No, I had, whoop, not too high now. I had like 13 decibels of headroom. Now I have like 3 decibels of headroom. Yep, thank you. Always tell me these things. Zoom kind of plays havoc with audio settings sometimes. Armanigu, so that's a good question about in-person administration of the quiz. I can accommodate a limited number of people doing that. I will send out something about that today. Thank you for reminding me about that. We will have a limited ability to offer the quiz in person to folks. When will you know your homework 1 feedback? You just turned it in on Friday, so the TAs will take some time to grade it. Unfortunately, it will likely not be graded by the quiz. But if you have any questions about homework 1, if you'd like me to do any of those problems now, there was also, so Amathis asks about solutions to recitation problems. We don't have those ready to go. Our intent is, if you have questions about the recitation material, just ask us. Ask us here, ask us in the physics clinic. Things like that are like a living answer, where you talk about the thing that you're confused by. And we give you a living answer is always better than just something dead. Jonathan asks for homework 6, or homework 1, question 6. Yes, I can address that briefly. What I'd like to do today, because we've got a lot to do, is here's the schedule for today. I want to review briefly what we did last time. I want to then give you some examples of how to use this material to solve problems. And then at the end of today's class, we'll do homework questions. So that will be at the end. We'll reserve the last 20 minutes of class probably to answer your questions about homework and requests for homework hints and stuff like that. So what we talked about before, there are 2 ways to represent vectors. Vector is just a thing with direction and magnitude. And I can either give you magnitude and direction. So I could say something like 40 degrees above the horizontal, 10 meters per second. Or I could give you components. I could say something like an x component of 4 meters per second and a y component of 3 meters per second. And you use trigonometry to go back and forth. This is what you practiced in recitation on Friday. Robert Lama says, can we go over vectors more? You found that kind of confusing. Sure. Yes, we will be talking more about that today, in particular the sorts of vector work that you will need for your quiz on Thursday. We will skip that slide. Last time, what we saw is that the kinematics relations, so these things that you have been using to understand how things move with constant acceleration, that if we're working in more than one dimension, so if velocity and position are vectors, I can just stick a vector sign on everything in those equations and everything still works. But in order to actually do algebra, I need to separate these equations into x and y components. So now I have 2 velocity relations rather than 1, right? So x and y for velocity, and then x and y for position. One hint that I will give you is don't put in the numbers until the very end. So as an example, if you have an object undergoing projectile motion, these are your 2 equations of motion, right? X and y, constant acceleration. And you might say, okay, well, if an object is moving through the air, like suppose I say, like for the first problem from your homework, I have a cannon, I launch a cannonball, I know it's, the initial velocity, perhaps what I'm trying to find in that problem. But you know, for instance, that it is not accelerating in x, but it is in y, and you can choose the initial position to be 0. So you might change the equation to this form and say, all right, I've put in my acceleration for y, which is minus g. I've put in my acceleration for x, which is 0, and the initial position terms have both gone away because we declare the starting position to be 0. And then you can go even further. You can say, all right, well, if this is being launched at a 45-degree angle above the horizontal, then I can replace the x component of the initial velocity by a trigonometric function. And we'll do the rest of this in a minute. So what I'd like to do now is I'd like to switch over to Blackboard mode and do some examples. Sajad, yes, we are recording. The recording will be uploaded to YouTube after class. It will be available on Twitch right away just because of how Twitch works. So what I'm going to do now, if you'll indulge me to click a few times, I need to turn off green screen mode just so I can use my green chalk. And we'll make this go away. Oh no! Oh no. If you could get that. We had you can't see it on camera, but one of the two, thank you. Thank you so much. I am so glad you were here. One of the two stands that holds up our green cloth just fell over. And our student who's here with us in person saved the day. All right. We've got this thing out of the way now. Mostly out of the way. I'm going to move the camera just a little bit away from the part of the board that has the shadow. There we go. So let's see. I need to click that button. Yes, we are good. So actually, I do want to show one more slide. I'm going to do this just without me. So here's one more slide that is a problem-solving guide for these problems. Any projectile motion question, any sort of kinematics question, you can generally approach with this series of steps. These slides are posted on the website, by the way. So the first thing you should do always is draw a cartoon. Pick your coordinate system, pick which location you consider 0. Then, if you've got vectors in this annoying angle and magnitude form, convert them to components. Then, write down your kinematics relations. Start with the most general form. A lot of the terms in them will be 0. In particular, if you have an object that is in free fall, then you know its acceleration in the x direction is 0. You know its acceleration in the y direction is g downward. And then step 3 is the piece we're going to practice a lot today. Understand the moment in time you want to know about and figure out a way you can frame the question that you'd like to answer in terms of your algebraic variables. Then finally, you do the algebra. Do the algebra that your statement indicated you should do. And then, at the end, go back, look at your solution, and ask what it means. So what I'd like to talk about now is that step 3. Suppose I have a hole. I'm standing here. And I take a ball, and I throw my ball up into the air and down in the hole. This has a height h. Suppose I want to ask the question, how much time does it take the ball to hit the ground? How would you frame that question in terms of your variables? What condition means the ball hits the ground? So let's write this. How do I ask that question in terms of my variables? While you all are typing, getting something. Okay. So, Christopher Vin, Kevin Busiak, Walter's hair in Twitch chat, I love it. Aki have all said two different things. So Catherine, Kelly, lots of people are saying, what is time when position equals 0? So let me just write down up on the board stuff people have said. What is t when x equals 0? That's one thing people have said. Also, people have said, what is t when x equals minus h? Another one some people have said is, what is t when v equals 0? So I'd like to talk about all three of these in turn. What's going on with these first two? People have told me two different things. What is t when x equals 0 versus what is t when x equals minus h? Christopher in Twitch chat has said they assume the lowest level is 0. The person's height is h. So yes, a lot of people are talking about a bunch of different things. In Twitch chat, you're both right. Yes, Dinara has it. They're different coordinate systems. So if you choose this coordinate system, which I'm labeling as number 1, then you've picked that as your 0 point. But this one that I'm labeling number 2 is this coordinate system. If you choose this to be your 0 point, then the bottom of the well is minus h. Right? So let me speak just about this one and erase some things so people will not be confused here. If you choose this coordinate system, you're putting your 0 up at the top, and that means that down here, x is minus h. That's the blue coordinate system. Or, if you do this one, we'll draw it over to the right, then if you say that this point is 0, then that point would be plus h. And you can freely choose your coordinate system. Either of those is correct. Is the chroma key on? Yeah, chroma key is stuck on. Let me fix that. Thank you. It's being a little bit wacky. Arg. There we go. Now chroma key's off. Oh, I have to click that button to fix it. Okay. So what I'd like to do now is apply this to two-dimensional motion. So I'm going to erase this, and we're now going to look at some things involving projectile motion. So what I'm going to do is I'm going to set up a situation, and then we're going to calculate stuff. So we're going to start with the simplest thing we can, which is a ball rolls off a shelf. So here is a ball. It rolls forward with some starting speed v0, and it's going to fly through the air and land over at that point. I'll tell you that this height is known. It is h. And I'd like to answer a couple of questions. We'll do how far from the base of the shelf does it land? First. So that means, in other words, we want to know this distance. So how are we going to do that? Sajjad, what does it mean to convert vectors into components? So suppose this didn't go straight. Suppose it started going up at some funny angle. So here's a sidebar. While you all are thinking about this, here's a sidebar to answer Sajjad's question. Suppose I said that my initial velocity vector was like that. And I knew this angle, right? What I need, because you're going to have separate equations for the x and y components, what I need are the x and y components of this vector. So we'll draw it like so. Here, if the magnitude of the vector is v0, then v0x is v0 cosine theta. Remember, cosine is adjacent over hypotenuse. And v0y would be v0 sine theta. Now, don't just remember that the x is always cosine and the y is always sine, because I could have given you that angle instead. So, Sajjad, does that answer your question? Good, good. So I see people discussing which of our homework problems this is similar to. So the problem we're doing here is somewhat similar to one of the problems on your homework. Porpoise, yes, it's sort of the second half of the Canon's motion. We will address that in a minute. That's a curious point. So here, lots of folks have said a bunch of stuff. So no one has given me a suggestion here. How am I going to find this distance? Okay, Waffle Sheep has said, take the time for it to fall downward and use that time with the horizontal velocity to find distance. Yes, that's what we're going to do. But I'd like to kind of do an intermediate step of framing a question in terms of our algebraic variables. This often is the thing that people get tripped up by. And to do that, we first need to choose a coordinate system. So where are we going to choose to be our 0 for x and y? Where will our origin of coordinates be? Okay, Christopher Vin Beckmunch has said the bottom. Crew says the top. So we got to choose. We have two places we could choose as our origin. This one or this one. Which one do you want, bottom or top? Luke says the bottom. Ian says the bottom. Rebecca says the bottom. Porpoise says the bottom. All right. Sorry. Robert, you have been outvoted. Martins says top 2. It would work either way, and we'll take a look in a minute at how that would go. But for now, this is x and y equals 0. And we'll also choose the conventional coordinate system. That's what you all will tell me to do. So now, in order to find this distance, d equals question mark, we need to frame this question in terms of these variables we've put on our diagram. So you want to write this as something like, what is blank at the time that blank is equal to blank. So what goes in these blanks? Yes, John, you are free to pick either coordinate system. Both of them will get you the right answer, just in slightly different ways. Yes, crew, both of them will work. So what goes here? What is x at the time y is 0? Yes, exactly. So what is x at the time that y is equal to 0? Because y equals 0, well, that's this line, right? By the math you told me to do. I know it can seem dopey to write out sentences like this, but this sort of framing guarantees that you won't make a mistake in the algebra. You all had been telling me, okay, what do I need to do? I need to calculate the time that y is 0 and then find x at that time. That's what you all told me to do, but that's one of those things where, like, if you didn't know to do that, how would you know to do that? And this is how. So now let's actually do our calculation. Yep.
Can you say at the time that h is 0 or no?
Oh, could I say, so she asks, could I say at the time that h is 0? So h is a variable that's given to me in the problem, and it's how tall the shelf is. We're using h to represent, like, maybe this is 2 meters tall or 1 meter tall. And it's just it's a fixed thing. It doesn't change over time. H is the height of the shelf, but for the ball's coordinates, typically we use x and y. Now, you could, if you wanted, you could rename a variable. You could say, all right, I'm going to call this varying over time x, and give, say, h as, all right, the varying height of the ball. But you'll probably wind up being confused if you do that, because, like, whenever we give you a problem where we say the height of the thing is h will be in your answer. And it's a fixed quantity, like 1 meter or 2 meters or whatever. Does that make sense? All right. Oh, and people are also asking, what does it matter that I started my ball here? That's a good point. We also should talk about origin in time. So we'll call t equals 0 when ball rolls off. Why do we do that? Well, remember that our equations are only valid when the acceleration is constant. And this thing doesn't start falling until after it passes the edge of the table. So our variable t represents how long the thing has been undergoing that acceleration. So now I've got the kinematics relations. So we're just going to write them down in their most general form. X of t is x naught plus v naught xt plus 1/2 ax t squared. Notice this is the same thing you've been working with. I've just added x's and y's. And this is true for any object undergoing constant acceleration, but here we know something about some of these variables. This is the most general form, but based on your coordinate system, which of these variables do I know? Yeah, Christopher has said ax equals 0. Why does ax equal 0? Yeah, there's no horizontal acceleration because in free fall, let me see how much room I have. Yeah, we're good. In free fall, the acceleration is g downward. Likewise, ay is minus g. So this equals minus g. What else do I know? Let's see. X naught is 0. So remember, we are starting at this point. And this is x equals 0, y equals h. So that's 0 equals h. What do I know about my initial velocity in x and y components? Initial velocity in y is 0. And the initial velocity in x is just v naught, because that's how fast it rolls. Because since it's rolling off the table horizontally, it's moving only in the x direction and not in the y direction. So now let's put those things in. I've kind of doodled all over these equations, but now let's write them explicitly with the things we now know. So x is going to be, let's see, that term goes away, that term goes away, and this is the only one I have left. V naught t. Y of t, let's see, I have h. This one goes away, minus 1/2 gt squared. Remember, the acceleration is minus g. Sajad says, doesn't it have to move horizontally in order for it to fall? Yes. So the x equation describes how it moves left to right, and the y equation describes how it moves up and down. Beckmanch says, how is v naught equal 0 if the bottom is 0? X naught. So how is x naught 0 if the bottom is 0? So x is this way. X is horizontal. And it's starting horizontally at this position. It's vertically up here. So x naught 0 because it's starting straight above the origin, but y naught is h because it's starting higher. Does that answer your question? Kwame says, what does x of t and y of t represent? These are the x and y coordinates of where the thing is at any point in time. So one way you could think of this, I'm going to erase some of these annotations here. You did a lot of things in school, I imagine, with a Cartesian coordinate axis, right? So something like this and like that. And if you think about this ball as it rolls off of the table, right, as it moves through the air in this arc, its x and y components of its motion, or x and y components of its position, will be changing. So its position vector at time 0 will be, use a different color here, will be straight up. But then sometime later, it might be over here, right? And its position will be given by some other vector, x of t, y of t. And as t changes, this position ordered pair changes until the thing lands on the ground. So what these two equations do is they trace out how this point moves as time passes. And yes, Jamie asks, why is the initial velocity in y 0? And it's because it rolls horizontally. The next one we'll do, it won't be horizontal. So we're starting with this one, and then we'll do one where it is at an angle next. So here are my two equations. Now, what does my sentence tell me to do? Well, it says what you in Twitch chat had been telling me to do, which is find the time that y equals 0, and then find x at that time. That's why this sort of thing is so helpful for you, because it tells you what algebra to do, right? This, again, is very general. This applies to all moments in time, but I know about one moment in time. I know that there's a moment in time when y equals 0, and I want x at that moment. So what I'm going to do is put in 0 there and write 0 equals h minus 1/2 gt squared. And then I solve this equation for t. Let's see. This gives me t equals square root 2h over g. That tells me how long it takes to fall. Look at it and see if it makes sense. This tells me it takes longer to fall if the shelf is higher, but it falls faster. It takes less time to fall if gravity is stronger. Makes sense. And then, once I've got that time, let's label this time required to fall, then I find x at that time. So I know x of t is v naught t. Let's see, now I know t, so that's v naught times the square root of 2h over g. And that tells me then how far it would go. So are there any questions about how we did this? What were the steps? We drew a cartoon. We understood our coordinate system. We figured out how to phrase a question that was the thing that we wanted. Then we wrote down our kinematics relations. We wrote them first down generally, and then we put in the things that we knew from the physical situation. Then we did the algebra described by this. Juriasi123 says, how did you find time again? I'm going to erase just some of this extraneous stuff. So let's put up our specific equations of motion for this problem again. We had x of t equals v naught t, and y of t was h minus 1/2 gt squared. And Juriasi is saying, how did we find t again? We know that the thing falls when this is 0. So we said, all right, that's 0. So we solved the equation 0 equals h minus 1/2 gt squared. And I skipped the algebra here, but to do that, you would move this to the other side. So you have 1/2 gt squared equals h. Then, let's see, I want to multiply by 2 and divide by g. So this gives me t squared equals 2h over g. And then you just take the square root of both sides. So Juriasi, does that answer your question? And yes, Shane. So Shane has said something really perceptive. Shane wrote, so whatever the initial velocity is multiplied by t tells you the x position at any time. So what Shane did was described the meaning of that equation in words. And it's always a good thing to be able to go back and forth between a description in words of what your equations mean and the equation. So keeping in mind the verbal meaning of your symbols is really important. So I'd like to ask another question here. So we're going to keep our setup, but now we're going to ask a different question. Instead, we're going to ask, how fast is the ball moving when it hits the ground? How would I do that? So Miles says, would these equations be consistent with this type of problem, or would they change depending on the value of the variables? They would change depending on the setup. So for instance, in this case, it rolled off horizontally, but maybe it doesn't. Maybe you have something starting at ground level and going in an arc. Okay. So Sajad says, I'm looking for the velocity this time. Kelly says, what is v when y equals 0? Christopher, what is v at the time y is 0? Beckmunch says, well, I should take a derivative. Yeah, the velocity equation is the derivative of the position equation, so that's right. Educational purposes is saying to add some vectors. V0 is Vx, so find Vy. So all of what you're saying makes sense, but I'd like to kind of start with Kelly's comment. So Kelly wrote, and I'm going to write some things in pink for a reason that you'll see. What is V when y equals 0? Okay. So we're going to modify this statement a little bit, but I want to put the kinematics equations back on the board, and we'll talk about those. So what we had before, we'll stick them over here. Actually, we'll stick them under here. So we have x of t is v naught t. That's from before. And y of t was h minus 1/2 gt squared. Can I find v with just the position equations? Siddiqui has told me I don't have enough depth of field. We'll fix that. So I'm going from f4 to f8. And now I'm going up to ISO 5000 to make it brighter. Thank you, Siddiqui. That's now fixed. I'm looking for the velocity. So what do I need to do? Well, I need my velocity relations as well. Remember Vx of t is V naught x plus axt. Vy of t is V naught y plus ay of t. Now, we already know that the initial velocity in y is 0. We also already know that the initial velocity in x is just v naught. What about the acceleration? Well, you also already told me what those are. You told me there is no acceleration in the x direction. And you told me that the acceleration in the y direction is minus g. So, looking for the right color, I have my velocity relations just like I had my position relations. But this is the bit that I wanted to talk about. Armani, I will come back to that in just a moment. Kelly said that I need to find v. But here I've got two equations that tell me v. I've got an x velocity and a y velocity. The question is, how fast? So if I'm trying to figure out how fast, do I want the x one, do I want the y one, or do I want something else? Dune says vector time. Porpoise says make a triangle, Pythagoras beckons. So what they're saying is how fast, this refers to the magnitude of v. So Kelly, I know you knew what you were describing there, but I kind of put this up to make a point. When we say what is v, what we really want is the magnitude of v. And finally, the word when is completely correct. But I don't like to use the word when here. I prefer to write this as at the time that. Because this tells you what to do. It says, oh, I need to solve for the time that y equals 0, and then find the magnitude of the velocity at that time. And yes, as Michael says, velocity is a vector, so it's got two components. One of those is changing over time, and so I need to later calculate that vector's magnitude. So let's do that. So statement of problem, kinematics relations. And now let's actually do the algebra. So first thing, find time when y equals 0. All right, that's pretty easy. I just set this equation to 0, right? I've got 0 equals h minus 1/2 gt squared. You've seen that before, right? So let's see, I move this to the other side. I divide by 1/2 g, and then I take a square root. And this will give me t equals square root 2h over g. I have again skipped a step in my algebra. So good question. So Sajjad has asked a wonderful question. He said, a vector needs a direction, and there was no direction mentioned in the question. Yes, you know that the velocity at this point, right, is going to be down like that. So here I have asked you for the magnitude of the velocity vector, but I could have just as easily asked you for its direction. And we will talk about that in a minute, because I'll show you how that works. Suppose I had asked that. So find the time that y equals 0. And then to find the magnitude of v, well, let's see. The velocity vector at that time, we know it goes down like this, right? That's v. But I know it has x and y components. Let's see. One here, one here. I know vy equals minus gt. I know vx is just v naught. And in this case, I know the time. So let's see, it's minus g times that. So minus g times the square root of 2h over g. But if I look at this equation, I can put this g in the square root sign as g squared. And that turns into minus square root 2gh. So now, given the x and y components, I can, as someone suggested, use the Pythagorean theorem to find the magnitude of v. So the magnitude of v is the square root of Vx squared plus Vy squared. I'm just color coding. And that's just going to be V naught squared plus that squared, which conveniently has a square root sign in it, like so. And that was the thing that I was supposed to find. Again, same steps as the problem we did before. We stated the problem in a sentence that involved our algebraic variables, and we had to think about like, okay, what does it mean how fast? Well, that's the magnitude of velocity at the time, and then we just did the math this indicates. We found the time that y equals 0 here, and then find the velocity vector at that time. So we needed both of its components. So let's see, the x component is just the initial one that doesn't change, and the y component was minus gt. Okay, we've got a lot of questions. Shane said, how did g get inside the root and into the numerator? I'm going to erase this. So what I did, Shane, was we had minus g times the square root of 2h over g. But that's equal to, I can put the g inside the square root as g squared, and then this cancels. So JM Chinko says, how did I go from minus gt to square root 2gh? So the time it takes to fall is that. So I should have color-coded that there. That time is just that, and then I did this algebra that I showed here. Sajad asked a bit ago, what about direction? Well, if I wanted the direction, I could maybe find this angle by trigonometry as well. Suppose the problem had said, which way is it moving? Well, I would, let's see, I know from looking at this angle that its tangent is going to be Vy over Vx, and at that point you just do some trig. Yeah, there's a question about where the minus sign went. Yeah, so when that minus sign got squared here, it turns into a plus sign. And people are, Mia Cohen, can I explain the last part again of how I got here? This is the Pythagorean Theorem, that this length is the square root of this plus that. And when I did the square root, Vx is just V naught, and Vy is minus square root 2gh. And when I square that, the minus sign turns into a plus sign, and the square root goes away. One thing that's important, I am kind of going through these things, the algebra quickly, but you will get practice on this algebra when you do your homework and when you do the recitation problems tomorrow. So any other questions about what we just did? You don't really get where t went in the last equation. So we figured out earlier the amount of time that it took for the ball to fall, right? We said, okay, let me look at the y equation. We had it up here before I erased it. Maybe I shouldn't have drawn my diagram so big. We had y of t equals minus 1/2 gt squared plus h. We said, okay, I can figure out how long it takes to fall by setting that equal to 0 solve for that time. So what I did was I plugged that time in here to get an expression for Vy that had the specific time in it. So Beckmunch has said, oh, okay, yeah, substitute. I don't know why I didn't see that. So this is a really good moment for how physics goes. Physics is 80 million simple things that all come at you all at once, and they're all individually simple. But the challenge is thinking about how to put them together to do the thing that you need to do. Why did I play the third movement, the fast movement of the Beethoven Moonlight Sonata before class? Playing the piano is really simple. All you got to do is push the buttons at the right time, right? You just push the buttons, and if you just push the buttons at the right time, it's so easy to play the piano. Anybody who's played the piano knows that's not easy. Physics is just like that, and that's why we have to practice. So we've got some time left. We can either talk about homework 2, if there are any particular problems you would like after to talk about with homework 2, or I can do another example that shows how to use the quadratic formula in these sorts of problems. So let's vote. Do you want to talk about homework, or do you want to talk about the quadratic formula? Homework 2. Homework 2, question 1. People want to do the quadratic, part 1A on homework 2. Homework, quadratic formula, quadratic formula. Zoom all wants to do the quadratic formula. How about this? We're going to do the quadratic formula here, and then I've got tons and tons and tons of office hours coming up. So 1 to 3:30 today, 1:30 to 3:30, and then 4 to 7 tomorrow, plus all of the coaches' hours. And those times would be really good to talk about homework. Homework is due Thursday before class, because the homework is preparation for your quiz, and I want you to do that ahead of time. I have another question for you. I would like both Zoom and Twitch to answer differently because you're on different video. Tell me, can you read all of the writing on the board? Am I writing too small for people to see? So Twitch is all saying that they can read. Zoom is saying they can all see. Okay, that means I don't have to draw such a huge diagram. So now we're going to be standing here with a catapult. And our catapult launches snowballs at some initial velocity, some angle above the horizontal. And the snowball flies up here and lands on the building. So what I'll ask you for, just in the interest of time, is where up on the roof of the building does this snowball land if it's got height h? This question was on the first exam 2 years ago. Your first exam questions will be slightly easier but similar in character. A similar question to this. So we got to find that point. I'll frame it in this way. I'll say, tell me this distance. Missing no, it doesn't matter whether we call it a quiz or an exam. It is a thing where I will ask you 2 questions, but you shouldn't stress too much about it. Okay, so where's this? We'll, as before, kind of in the interests of time, choose our coordinate system like this. So our coordinate system will be lined up with the snowball launcher. So as before, we need to translate this question into a sentence about our variables. So here's our template. what is the value of blank at the time that blank equals blank. How do I do that? What is x when y is h? Yes. So we want to do that. Okay. What's the next thing that I need to do? Just going to check my time here. Oh, we got 8 minutes, so I'm going to go a little bit quick. I need to write down my position relations. Clearly, I need x and y of t. So x is going to be, we'll color code here, v naught xt plus 1/2 ax t squared. Y of t is v naught yt plus 1/2 ay t squared. Now, I can do some of this with my eraser, which I'm going to. I know the acceleration in the y direction is minus g. We'll color code here. Minus 1/2 gt squared. And I know the acceleration in x is 0. Now, though, what do I do with the fact that I don't know components? How do I handle the fact that I don't know v naught x, I don't know v naught y, I know magnitude and direction? Cosine and sine. Trig, yes, exactly. So here's v naught. Let's see, I know this angle. So v naught x is going to be v naught cosine theta. And v naught y is going to be v naught sine theta. Because cosine is adjacent over hypotenuse, sine is opposite over hypotenuse. So I can substitute those things in. This is going to be v naught cosine theta times t. And this is going to be v naught sine theta times t. Now, a lot of people are doing something really good in chat here. Oh, let me hold up and get some questions. Why is the x acceleration 0? Because gravity pulls things down rather than to the side. Jay Lee says, why is the acceleration still minus g when it's going upward? Because even though it's going upward, gravity is making its y velocity become less and less and less. So if I take one of these pieces of broken chalk that litters this room and I throw it up, it moves upward and is always slowing down as it moves upward. And then it moves downward and speeds up. So a negative acceleration could either mean you are moving upward more slowly, or you are moving downward more quickly. Armani says, but the little snowball launcher gave it a force. Yes, but after it leaves the snowball launcher, that force has gone away. And this problem, we're not thinking about how the snowball launcher works. All we know is that it yeets things at a speed v naught at an angle theta above the horizontal. And Porpoise says, when does it exert the force? Does it exert a force over the whole flight time? No, Once it leaves the launcher, it's done doing its job. Yes, you're going to yeet things in recitation tomorrow by request of the problem that we have a physics coach who is famous for throwing a boot into a stream, and she is yeeting her boot into a stream in recitation tomorrow. No, I will not do the yeet vine dance. So what do we do now? Some folks observed that we want the value of x at the time that y is h. And people said, wait a minute, there are 2 times when y is h. I'm just going to check time. I got 3 minutes. Let's finish this real quick. So we want to find the time that y is equal to h. So I've got h equals v naught sine theta times t minus 1/2 gt squared. Minus 1/2 g times t squared. This is a quadratic equation. It's got a t squared, it's got a t, and it's got a nothing. So how do you solve quadratic equations? You put everything on one side. So this gives us, I'm just going to stick everything on the left. I'm going to write the terms in the standard order. So I have 1/2 g t squared minus v naught sine theta t plus h equals 0. Now, the quadratic formula says that t is equal to minus b, whoops, I'll color code this, minus b plus or minus the square root of b squared minus 4ac all over 2a. And these capital letters refer to the coefficients of these 3 terms. That's the a term. This is the b term. And this is the c term. So we are out of time, but to get 2 values of t, you would just stick these 3 things into this equation, and notice the plus or minus here gives you 2 answers. Now I'm going to get 2 answers, as we said. Which one do I take? And people have said, well, it's the big one, right? So when you use the quadratic formula, that's the small value of t, that's the big value of t. So for the Roadrunner problem, you wanted the small one. For this problem, you want the big one. And the only way to know is to think about it carefully and to go back to your cartoon and to think physically about what's going on. This is all the time we've got for today. So thank you all for bearing with me with this technical stuff. You will get lots of practice tomorrow for your homework. So here's the thing. Let me make a deal with y'all. You've got a lot of work to do in the next 2 days for homework 2. Homework 3, we will have more time on. So devote a little extra time Tuesday, Wednesday, Thursday to Physics 211. And then you'll get a break the following week with a short, easy homework set. Thank you all. Cruz says, what is the significance of the smaller value? The significance of the smaller value is it tells you at what time the snowball first reaches that height before it lands back on the roof. So maybe you were interested in that value. Maybe you're trying to calculate whether it strikes the corner of the building or not. You'd use that. This problem, we're not interested in that one, but that's the significance. Gracias, the Pizza Man 430. I will stick around and answer any questions that people have. Otherwise, I will be back in the physics clinic at 1:30 to answer anybody's homework questions. I'll be there from 1:30 to 3:30. JM Chinko, how did I get this? So the trigonometry here, let's erase this. So this is V naught x, this is V naught y. And you know, well, we'll do colors. So you know, for instance, that sine theta is opposite over hypotenuse. So V naught y over V naught. And cosine theta is V naught x over V naught. And by moving the V naught over to the other side, you get those two components. Matthew, yes, exactly. You would solve this for t. We can finish this Thursday if you want. You would solve this for t using the quadratic formula. So you'd put in a, b, and c, get a value of time, and plug it in there to find y. Exactly. Eddie says, that's important for hitting targets in defilade in artillery. Yeah. Remind me again, I forget the difference between defilade and enfilade. It's been a while since I read that. Shane says, in simple terms, what's magnitude and direction? So magnitude is the length of the vector, and so it's found by the Pythagorean Theorem, and direction is that angle. Defilade is this one. Yes. So how do you finish the problem after the quadratic formula, Maya? I can stick around and do this in like a couple of minutes. I know it's the end of class. I know you all are leaving. But Maya, if you want to hang around, I will finish the algebra. Otherwise, I can do that Thursday. So you would stick in these values. So let's see what you get. Oh, Maya says never mind. We'll pick this up Thursday. I'm going to kill the recording. I will stay here for any